All right, it's 12 o'clock. Good afternoon, everyone, and welcome to this week's Iowa Learning Farm Conservation Webinar. I'm Matt Helmers with Iowa State University. Excited to be back hosting the webinar this week after being away for a while and not being able to participate. So really excited for this. I'm here while the rest of the Learning Farms crew is down at the Iowa State Fair with the wetlands trailer. So this week, really excited to welcome Eric Henning to talk about the work he did as part of his master's degree. And so Eric is a PhD student in the Ag and Biosystems Engineering Department. I have the great pleasure to get to work with Eric and got to work with him as while he did his master's. Eric's a native of Iowa, but got his BS at University of Nebraska-Lincoln. So Eric and I have something in common in our love for the Cornhuskers. So with that, I'll turn the virtual floor over to Eric, and he's going to talk about his work comparing infiltration between prairie strips and row crop fields across Iowa. With that, Eric, the virtual floor is all yours. As always, if folks have questions, feel free to type those in the chat box, and I will get those to Eric at the end of his talk. Okay, it's all yours, Eric.
All right. Thanks for that introduction, Matt. And thanks to everybody in the audience for joining me today. I'm really excited to share some of this work, as Matt mentioned, for my master's thesis. So yeah, we'll jump right into it. So the topic of today's presentation is comparing infiltration between prairie strips and row crop fields across Iowa. And to start off, I'm just going to provide a little bit of historical background and provide some context for some of the work I'll be presenting on. I'm sure this is probably a review for a lot of those in the audience today, but I'll still go through it briefly for maybe some of those who aren't familiar. Up on the screen, I have two land cover maps of the state of Iowa, the one on the left coming from the mid-1800s before European settlement, and the one on the right coming from 2015. So you'll notice in that mid-1800s land cover map, much of the state is covered with the tan color, which represents prairie. Fast forward 150 plus years, and much of that tan has been replaced with the dark green and yellow color, which represents corn and soybean row crop land. So in fact, there's been a dramatic landscape change in the state, and Iowa has lost over 99% of its historical 12.5 million hectares of tallgrass prairie. Now, with that dramatic land use change, there have been some soil and water quality consequences, including soil erosion, soil carbon decline, and nutrient loss. With this transition from a perennial landscape with native prairie to an annual cropping system across much of the state, our soils are left uncovered on the tail end of the growing season, as you can see in that picture on the top left under the soil erosion heading. Unfortunately, this can be kind of a common sight as you drive across our state in the spring, where gullies form after a big rain. And that map on the bottom left comes from the Daily Erosion Project. It shows hill slope soil loss for up to 12 watersheds in the state. And I just included that to point out some of those darker areas, which represent areas that are a little bit more hilly and vulnerable to soil erosion in the southern and northeastern parts of the state, which contrast with the north central, which is a little bit lighter. It's a little bit of a flatter landscape. Going along with the soil erosion issues, a recent study showed that in Iowa and regionally, the average cropland is at a 45% deficit in soil carbon when you compare it to native grasslands. That presents a little bit of a potential carbon sink in our landscape. And then additionally, I know this is another topic that's definitely been covered in a lot of these webinars, but the nutrient loss associated with our cropping system is a big issue. The loss of nitrogen and phosphorus into waterways creates numerous water quality issues, including the infamous Gulf hypoxic dead zone in the Gulf of Mexico. So now jumping into the STRIPS aspect of this presentation. STRIPS stands for the Science-Based Trials of row crops integrated with prairie strips. This is a project that was started at the Neil Smith National Wildlife Refuge in Jasper County, Iowa, a little over 15 years ago. And the initial phase of the project was taking 12 small watersheds within the refuge and converting them to different arrangements of combinations of no-till corn, soybean row crops, and then reconstructed prairie, both at the foot slope and along the contours and strips. So there's 4 different treatments: the 100% row crop, 10% prairie at the foot slope, 10% in contour strips, and then 20% in contour strips as a percentage of land area. And on the right's a picture of one of those small watersheds. So this initial phase of the strips project, we now refer to it as strips 1 or phase 1, which ran from 2007 to 2012, taking place at the Neil Smith Refuge. And it established some very encouraging results. Strategically adding 10% prairie to the no-till corn soy fields resulted in 37% reduction in water runoff, 95% reduction in sediment loss, 77% reduction in phosphorus runoff, and 70% reduction in both nitrogen runoff and subsurface nitrate concentrations in these non-tiled fields. So fast forward, building off of the momentum that the Prairie Strips project, the phase 1 portion of the project established, Strips moved into phase 2, which is on-farm research and refinement. So this would be monitoring and researching strips that have been implemented on fully operational farms across Iowa and the region. There's over 80 collaborators as of today participating in this phase 2. Here's a beautiful aerial image of one of those fully functional strips phase 2 sites in Pottawatomie County, Iowa. And this is one of my favorite sites. I actually will be presenting some data that I collected from this site later on. Now, alongside the strips 2 on-farm research and refinement, another development happened in 2018 when prairie strips were included in the Agricultural Improvement Act, or the Farm Bill. So under practice CP 43 in the Conservation Reserve Program, participants can implement prairie strips on their farms and receive payment and cost share for establishment costs, with the goals of providing ecosystem services such as soil erosion, improving water quality, and then also wildlife habitat. Under CP 43, there's certain requirements for the size, placement, and seed mix of the prairie strips, but they can be pretty adaptable to hopefully kind of seamlessly integrate into any operation. As of today, there are over 18,000 acres of CP 43 prairie strips across many states in our region. And as I mentioned, prairie strips, CP 43 prairie strips can take many forms under the guidelines in the CRP program. So at the top left, you have a picture of some long, straight, wide prairie strips. And then on the right, you have maybe narrower strips that are planted along the contours of the field. And then on the bottom left, you again have just straight strips that are just at the field edge, but then also they widen out along flow paths. So they're highly adaptable and can really, I think, integrate seamlessly into any operation. So with all that said, now delving into the actual research that I'll be presenting. Given all the context I mentioned, the question we wanted to answer was what's actually going on in the soil with regards to infiltration in the prairie strips across the state. So to start off, I just want to present a little graphical representation of the hypothesis that guided the research. So here on the screen, we have an example cross-section of the prairie strip field. And I think right off the bat, you can notice that there's quite a difference in the root systems of the two plant communities. This picture maybe isn't perfectly to scale, but it's fairly representative. And along with some other factors, we think this might have an impact on infiltration dynamics. So in the crop field, the annual crops, they're bred to maximize grain yield every year. So they invest most of their energy above ground and don't form quite as extensive of a root system. Along with that, another factor that can affect infiltration would be tillage and wheel traffic from field operations, which disrupt the soil structure. In contrast, when we look at the prairie strips, they have this extensive root system. Native prairie species adapted over millennia to withstand the climate extremes of the region. So they invest a lot of their energy into their roots to be resilient year after year. Along with that extensive root system, we have the buildup of soil organic matter as a result. And since these are not crop systems, there's minimal soil disturbance. There's no field operations to kind of disrupt things in the soil and maybe reduce infiltration capacity. So all in all, these factors that I mentioned are important because they affect the distribution and abundance of macropores within the soil profile. So macropores are essentially the relatively large air pockets within the soil, which are the most important factor when we consider movement of water through the soil. So macropores can be affected by some of these things that I mentioned, like organic matter and root channels, but also inherent soil properties like sand content. I think we all, kind of inherently know that sand infiltrates better than finer textured soil. So now when we compare macropores and infiltration between row crops and prairie strips, our hypothesis goes a little like this, where, okay, we have an example rainfall event. The row crops, we would think maybe have relatively lower capacity to infiltrate water. So surface runoff is produced, sediment is carried with that runoff, and then the runoff reaches a prairie strip where there's a greater ability to infiltrate water. The runoff slows down, soaks in, some of the sediment settles out, and the landscape is able to store more water, and less and cleaner runoff runs down slope. And with every consecutive prairie strip, this outcome is hypothetically observed. So ultimately, we have better soil water storage on the landscape and cleaner, less runoff running off. So to test this hypothesis, we employed a few different methods. The first being the tension infiltrometer. It's a piece of equipment that we used at actually the phase one, the Neil Smith sites, two of the small watersheds. We ran tension infiltrometer experiments both in 2010, 2011, and 2021. So we have 3 different time periods and 2 sites that we're looking at. We had a paired design where we take tests in the prairie strip and then directly upslope 3 meters into the row crop field. And we represent 2 different landscape positions, both top of the hill and at the bottom. So the meaningful variables that we measure with tension infiltrometer are values of hydraulic conductivity, which is just the soil's ability to conduct water. So I won't get too into the weeds about how the equipment actually works, but what's kind of neat about the tension infiltrometer is we can basically control which size pores are actually conducting water. So we'll set a tension on the equipment, and at the smallest tension, only the smallest micropores will have water flowing through them. And then at the largest tension, or kind of like saturated conditions, it's really the largest macropores that have water flowing through them. And this is represented in our hydraulic conductivity measurements. So here's just a picture of the team out in the field performing this experiment. Now, taking a look at some of the results, here I have 4 or 6 plots representing the 2 sites in 3 years. We have hydraulic conductivity on the y-axis, and then the different tensions that we set with the equipment on the x-axis. And honestly, there weren't really any obvious trends with regards to the treatments, other than the data was highly variable. It's a little disappointing. It's hard to really find too much occurring over time. However, if we focus in a little bit and take a look at this table, which I have the differences in hydraulic conductivity between the prairie strip and the row crop. So a negative value would signify that the row crop has greater conductivity than the prairie strip, and a positive value would be the opposite. If we zoom in on the red box at the Weaver 2 site, in 2010, the row crop had greater saturated hydraulic conductivity than the prairie strip. But over the course of 11 years, after we tested again in 2021, the opposite was observed, and we had significantly higher saturated hydraulic conductivity in the prairie strip than the row crop. Kind of on the other end of the spectrum, when we look at that yellow box on the table, that would be the lowest tension, or the micro pore flow. We observed the opposite. In 2010, prairie strip has greater hydraulic conductivity. In 2021, it's the other way around, and the row crop has greater conductivity. So these two observations kind of suggest that maybe there is some relatively greater macropore development in the prairie strip relative to the row crop, and greater micropore development in the row crop compared to the prairie strip. Next, I mentioned we used another piece of equipment to do infiltration tests, and this was the Cornell sprinkle infiltrometer. So essentially how this works is you just have a portable rainfall simulator that you set on top of an infiltration ring, and a tube running at the soil surface from that ring to collect any runoff that's generated. By taking measurements throughout this process of rainfall simulation, you can measure a rainfall rate, and simulate rainfall rate, and a runoff rate. And then with the difference of those two values, you have an infiltration rate. So the meaningful values I'll be reporting on are the field saturated infiltration rate. So after about half hour of rainfall simulation, there's steady state conditions, and infiltration rate kind of flattens out, and we have the infiltration capacity basically of the soil. But then we also can measure the sorptivity, which describes the early infiltration and is related to the time it takes to generate runoff on the soil. So this is a pretty cool measurement, but I will mention that it does vary with initial soil moisture. As you can imagine, a wetter soil would generate runoff quicker than a drier soil. So it can be hard to compare sorptivity values between like two different time points or sites. The way we got around this was, but with our experimental design, we had a paired design again, where we have a testing point in the prairie strip and then directly upslope in the row crop. And we measured these points simultaneously so that both the prairie strip and row crop treatments experience the same environmental conditions up until that testing point. We conducted the Cornell sprinkle infiltrometer experiments across 6 sites across the state of Iowa. So we have 2 within the Des Moines lobe, and then 4 on the southern Iowa drift plain. Of these 6, 3 were sites where we measured on 3 separate occasions in the fall of 2020, summer of 21, and fall of 21. And then the other 3, we only took measurements in the summer of 21. And I should mention all 6 of these sites had prairie strip establishment between 2014 and 2015. So they're between 5 and 7 years old by the time we took the infiltration measurement. Now digging into some of the results we observed, here up on the screen, I have ox plots for field saturated infiltration from the summer 2021 sampling campaign. And we have the prairie strip in the red and the row crop in the yellow. And these are field saturated infiltration rates and distribution of them. And kind of a similar story to the tension infiltrometer. Really, the most obvious thing is just that we have a lot of variation. We didn't see any statistically significant treatment differences at any of the sites or across any of them combined. However, again, here I have field saturated infiltration rates. And these are just at the 3 sites where we measured on 3 separate occasions, all combined together. And when we look at all the 3 years for these 3 sites, we do see that there's one site, the road site in the middle, that has significantly higher field saturated infiltration within the prairie strip than the row crop. While on the other hand, the other 2, there's essentially no difference. Moving into the sorptivity, the early infiltration, we did see some significant results here, and we found that the prairie strip had greater sorptivity than the row crop, but here's the caveat, it was only during the fall sanding periods. During the summer, there was like no difference at all. So this was kind of an interesting development that I'll talk about a little bit later. So now just to kind of explain some of these results, here up on the screen, I have the field saturated infiltration. Actually, these are just site characteristics for each of the sites that we measured field saturated infiltration. So the big question we asked once we got our results was, okay, there's 5 phase 2 sites that have no differences, but one that does. How come? Like, what is special about this site? So the first thing that I'll point out is the sand content. Those 2 Des Moines lobe sites, you'll notice, have significantly higher sand content than the remaining sites. And this is important, as I mentioned, that sand can kind of control hydraulic conductivity and saturated infiltration. So we think maybe just those sand effects kind of outweighed any differences between the 2 treatments, the prairie strip and the row crop. So that we just couldn't observe enough contrast between the 2 treatments because the sand was kind of in control. And even when we look at the phase 1 sites at Neil Smith, where there really wasn't too much of a significant outcome, but there was a slight outcome, prairie strip enhancement at the Weaver 2 site. It's interesting that field actually had lower sand content than the others. So maybe there was a little bit more contrast that could be evident between the prairie strip and the row crop. Next, considering the tillage practices within the crop fields, you'll notice that several of the sites are conventional till while several are no-till. And again, this is kind of a story where maybe the effects of no-till kind of match some of the effects of prairie strips when you consider just like the minimal disturbance on the soil in the soil profile. So again, maybe just those no-till impacts kind of outweigh any potential differences we could see between row crop and prairie strip, and just kind of dampens out any potential differences. So we have 2 remaining phase 2 sites up on the screen. One of them had significant differences and one of them didn't, and they both look very similar in terms of soil texture and tillage practices. However, when we look at the organic matter concentrations of these sites, we noted that the road site, the one that had the infiltration enhancements and prairie strips, across both treatments, it started with significantly less organic matter. And by the time we tested, there was actually significantly greater organic matter within the prairie strip than the row crop. On the other hand, at the McNay site, it already had relatively higher organic matter percentages within those soils. So with all that said, I think really the road site, just by a combination of factors, we think maybe it just had it was like it was primed to see those early boosts in infiltration from the establishment of prairie strips, because it was already like operating at kind of a deficit, and it could boost organic matter could be boosted right away from prairie strips, where on the other hand, from these other sites, maybe not so much. Moving on to the sorptivity results, how do we explain these? You know, as I mentioned, we saw seasonal changes. Only prairie strip advantage in sorptivity during the fall. So this led us to think, well, maybe there's not a soil structural change that's causing these observed differences. Maybe it's has more to do with soil moisture. So you look in the literature, and I mean, it's intuitive, but in perennial vegetation outside of the annual growing season, there's increased water use and evapotranspiration. So soil tends to be drier in perennial crop or perennial vegetation as opposed to row crop. So basically, in the prairie strip, it was just a little drier, and runoff was generated later than the row crop. Now, this may seem like a little inconsequential, but when we actually think about it in the context of that hypothesis, it definitely is meaningful. It means that outside of the growing season, when our lands are maybe the most vulnerable to soil erosion and runoff generation, prairie strips are more like ready to accept water and infiltrate water, and have enhanced soil water storage capacity. And we can kind of confirm our hypothesis that a field with prairie strips would have better soil water storage and cleaner, less runoff running off the field than a 100% row crop field. So just to kind of tie it all together with some conclusions, some takeaway points. Regarding our saturated infiltration results, we didn't see consistent differences between prairie strip and row crop across our 8 different sites across the state. There's really one site that had strong differences between prairie strips and row crops at 5 to 7 years post prairie strip establishment. And this site was just unique in that there was a very small sand content in soil, and the row crop field was conventionally tilled, and there was a low starting organic matter content in the soil. So it was just, as I mentioned, it was just kind of primed to see early changes with regards to aquapore development and saturated infiltration. With these other sites, I mean, at this point, we can speculate that maybe it'll just take longer for some of these changes to develop. Our hypothesis, we could potentially revisit that in several years, but at this point, we can't really make any strong statements about prairie strips enhancing infiltration capacity. On the other hand, with our sorptivity results, the early infiltration and the time to runoff, prairie strips did have an advantage over row crops in this category. So, but like I said, it was only outside of the annual growing season in the fall. So, however, this is an encouraging result. It means that when our soils or our land may be most vulnerable to infiltration, to runoff, and we need enhanced infiltration, the prairie strips can provide that. So that takes me to my acknowledgements. I just want to acknowledge these organizations for their support in the project, and I will turn it back over to Matt.
Okay.
Thank you.
Thanks, Eric. All right. So if you're on today and need a CCA CEU, please email Alena Whitaker, ALENAW @iastate.edu by 5 o'clock today, and include your name, the name you entered to watch the webinar, and your CCA number. Again, Alena W @iastate.edu. And we can go to the next slide. Eric, this should be the demographics. If you watch this webinar live and are willing to fill out the voluntary demographic survey, we would greatly appreciate it. If you've already filled one out for a 2023 webinar, you're off the hook and don't need to do it. You can scan the QR code. If you're quick, we'll try to leave it up there a second longer. Or you can go to iowalearningfarms.org/survey. So again, if you're willing to fill out this voluntary demographic survey, we'd greatly appreciate it. And again, only one survey response is needed for 2023 webinars. And let's go to the next slide, put in a plug for next week from the Iowa Environmental Council, Alicia Vasto on CAFO impacts and rulemaking. So tune in to that. Let's go back, maybe go back to kind of your conclusion slide, Eric, there, and we can, we do have some questions in here. Okay, so first off, and this might be a little more of a question for Tim Youngquist, because some of these are on implementation, but whether they have had farmers flexing the width of the strips across the field to achieve a consistent number of rows between strips. I guess I can answer that one. Yes, not necessarily flexing the width, but and maybe in some cases, but they have a determining factor in the width between strips has been based on kind of their most limiting farm piece of equipment, which in a lot of cases for non-organic has been the sprayer width. Somebody asked how long the prairie strips were established before the research started. And I think you kind of talked about that. How might your results compare to contour strips with alfalfa or wheat?
Okay. I wouldn't be totally familiar with alfalfa or wheat, but I could presume that any perennial crop or perennial vegetation, we might see the same sorptivity, the same early infiltration results, just because you'd have increased evapotranspiration outside of that annual growing season. But as far as like infiltration capacity, I don't know if I could speak to that.
There was a question here is what's the attitude of Iowa farmers with respect to increased weed pressure that may come from prairie strips? And
Okay, sure.
yeah.
Yeah, and Matt, yeah, feel free to help me out.
Okay, I could
if
jump
you
in a
have
little
opinions,
bit too.
but
Yeah.
there has been some research showing that the impacts of prairie strips with regards to like increasing weeds within the field is negligible. As far as the attitude of farmers goes, I'm not 100% sure if we've done like a survey on that or not.
Yeah, I think that's probably right. Certainly, I'm glad that yeah, that even though that work was done before you started here at Iowa State, that's what Matt Liebman had shown at Neil Smith National Wildlife Refuge, that there wasn't a increased weed pressure, increased presence of weeds adjacent to the prairie strips, but there probably is maybe some perception at times, and so that's a reason why we did do. Why they did do that work. Okay. Another implementation question. Does a conservation practice standard apply for rural residential properties thinking of converting large areas of mowed turf to prairie strips?
Yeah, that would be one where I'm not familiar.
Nope. And I can't help you out on that one either. I'm not sure about that one. Okay, there was one here. How were the prairie species selected? Was consideration taken into account the soil types or the amount of rainfall that might be expected?
Okay, sure. Yeah, so the seed mixes can kind of vary by what your goals are for the prairie strips. A more like grass majority seed mix might be more economical, and it might have more benefits with regards to like erosion control and infiltration and stuff like that. Soil and water conservation considerations. On the flip side, if you have like more of a forb heavy mix, it might be a little bit more expensive, but obviously you're going to get more pollinator benefits and potentially some just like wildlife benefits. So really, yeah, it's kind of up to the landowner how they want to go about that, but there's pros and cons to any mix that you choose as long as it's native prairie species.
There was somebody put in the chat, CP43 would only apply to cropland. So
Okay.
the turf, yeah. When doing conservation planning with farmers, Russell 2 is used. Was the planning of the contour prairie strips based upon how Russell 2 is used when calculating soil loss with the contour grass buffer strips? And I think that that would be more of a question for, I don't know if you know that one, Eric, maybe for
Yeah,
Tim
I'm not familiar
Youngquist.
with them.
Yeah. So that might be a reason to get Tim on here to talk about some
Yeah,
of, maybe on some of his kind of broad observations in working with farmers across the region on the implementation. And somebody put in here, great comment. Just a comment. I think there's more likelihood for weed pressure to form with cool season grasses than native grasses because of the bunch forming nature.
hmm,
Yep, and that
that's a good point.
rigid stems of the natives also might provide nutrient reduction benefits greater than wheat or hay. And I would say that's especially with that runoff, that stiff stems are going to hold up better during a runoff event. Okay, let's go. Okay, this is a good one. Do you see this practice as a feasible replacement for grassed waterways on potential or established gully erosion sites?
Okay. Well, I would say I think they can go hand in hand. Let's see if I can get all the way back. So yeah, for instance, at this site, we both have a grass waterway and prairie strips. Um, and I think they both can serve their purpose here. And potentially there's some like either an additive or multiplicative effect by having both. Um, obviously with the waterway, it's designed to move water off. In contrast, the prairie strips, which are on the contour and have the stiff stems, like that was mentioned, to slow water down. So yeah, they kind of go about solving the same problem through different means. Um, and then on top of that, with the prairie strips, they have some additional benefits as far as like habitat goes and pollinators and other ecosystem services. So yeah, I would say I don't know if it's really about replacing one or the other, but I would say they can both work hand in hand.
Yep. Next one, farmers are allowed to drive on the prairie strips during farming operation. For example, turn on them. How might that impact infiltration dynamics?
Yeah, so that's an interesting point. That would be a factor that could play into some compaction potentially on the strips. Especially I don't think you're allowed to, but if the strip becomes a driveway, uh any infiltration benefits probably you're not going to be seeing those. So um yeah, that it could have potential impact. I don't think, you know, uh probably wouldn't be happening too much. Yeah, it's such a small area, but yeah, certainly wheel traffic would have a negative effect on infiltration.
Um, okay. How much rainfall prior to the infiltration measurements, and did you observe any soil crusting or visually observe differences between the conventional till and no-till sites?
Yeah. So when we went out and tested um summer of 21 and fall of 2020. So at some of the southern Iowa sites, it was actually pretty wet. Uh in the lobe sites, and it was definitely very dry. So we had a representation of both conditions, I'd say. Um, Visually, as far as like crusting goes, I don't recall too much of a difference
Okay.
between the conventionally tilled and the no-till. But yeah, that's certainly been documented. So
This one, did the no-till sites use cover crops?
not to my knowledge.
Yeah. I don't think any of these sites use cover
No.
crops. Certainly that would be something that could be incorporated, but yeah, we just looking
Yeah.
at the impact of the prairie strips. Could you envision that that these might need periodic maintenance or renovation?
Yeah. So maintenance, there's a maintenance timeline, there's resources on the strip's website, but during the establishment phase, I know mowing is encouraged, which that kind of the perennial crops or the perennial species that invest in the root system have an advantage after mowing compared to the annual weeds that just shoot right up. And then more longer term, there'd be like spot spraying, occasional mowing, burning. Um, Remind me, I think that would be the main aspects of maintenance. And then, yeah,
Yeah,
do you have anything to add?
yeah, I would. One thing I would add, we at Neil Smith, especially where we didn't have grassed waterways, we saw a lot of sediment deposition on the upstream edge of the prairie strip. Saw maybe a little less of that at the phase 2 sites because we didn't have some of that ephemeral gully erosion because of the grassed waterway. But in that case at Neil Smith, you know, at least over 10, 12 years, we didn't have to do any maintenance there, but I could see that, you know, if you had enough sediment deposition, you might have to you know, move that out a little bit. Kind of creates a depositional wedge there. I guess from your work, Eric, did you see, I guess, that the prairie strips were robbing moisture from the nearby row crop areas?
Okay. I could only speculate. I
Mhm.
think Cole Dutter may have done some work
Yeah,
looking at this,
yeah.
and I I, I can't say for sure what he found. I know, yeah. Matt, did you?
That's what I'm the same. I can't exactly remember. So as I'm going through this, I'm like, we need to have Tim Youngquist on here to do a presentation on the kind of some of the implementation, what he's seen, and maybe Cole to talk about some of his work that's looked at soils and a little bit on impacts adjacent to the
Mhm.
prairie strip area. I think in general, there's been very little impact adjacent. Yeah, Tim's
Yeah,
around whenever. So okay, we got you
and
on, Tim. We'll get you on. Yeah.
one thing I'll add to that is, I guess, kind of our sorptivity results during the summer would suggest that there was no difference in the soil moisture. Uh, yeah, during the peak of the growing season. So,
Yeah. So that we might expect that reduced soil moisture to be more in the spring and the fall of the year. That was one of my
yeah.
questions. Okay, I'll take my prerogative as a moderator. So you measured in kind of the early summer and the fall. If you had
Hmm.
been able to make these measurements in the spring, you know, say in late April, early May, what might you have speculated for some of this?
So I would guess that we'd see very similar results to what we observed in the fall. Um, our explanation for why there's a sorptivity difference in the fall was related to soil moisture and related to increased evapotranspiration in the perennial vegetation, and therefore lower soil moisture. So I would anticipate similar results, and that's kind of what I suggest. Yeah.
Okay. All right. All right, in the interest of time, I think we'll so I think some other good comments about controversy over mowing that they're this person says it's not necessary. There'll be weeds in the first couple of years, no matter what you do, and that year 3 and beyond, the prairie plants will start to outcompete the weeds. So I do think that some of that brings up. It'd be great to have Tim and maybe also somebody from the Tallgrass Prairie Center talk in the near future on a Learning Farms webinar about management of these areas. There was one last one. I'll let Wade get the last comment in. He was curious about the water holding capacity in the strips versus cropland in the heat of the summer and what you might speculate on that.
Okay. The water holding capacity we would in general think that would be related to soil texture and organic matter. So if we see differences in organic matter in the prairie strips as we did at the road site, I would anticipate higher water holding capacity. But aside, if we don't have the organic matter differences, I don't really know if there'd be enough evidence to say that prairie strip would have increased water holding capacity. There is that extensive root system, which I guess could play a role, but yeah, that's where I'd leave it for that question.
All right. Eric, maybe we can go to the slide for the CCA credit, or actually I can just read that. If you're on to that you need a CCA credit, please email Alena W, so ALENAW at iastate.edu by Wednesday, August 16th, which is today, by 5 o'clock with your name, the name you entered to watch the webinar, and your CCA number. With that, I want to thank everybody for participating today, and please tune in to a future Iowa Learning Farms webinar. And these are all archived, so you can go back and watch them as well. With that, thanks a lot, Eric.
Good, thank you.